Hi there once again and welcome to another Expresso mechanics tutorial. And in this one we're going to be building this, which is a folding door rig. Now if we just run the timeline you can see how it works. It can be very uniform, but if we just get a hold of our controller here and we adjust this manually, we can also see that it can be set up quite chaotically. It doesn't have to be ordered. So we've created an algorithm within Expresso that actually allows this situation to occur. And that's what we're going to be about in this tutorial. So without further ado, let's see if we can make this happen. The first thing we need to do is set up the positions of our, what I'm calling inner hinges, because there'll be two sets of hinges for these doors. So we'll set the inner hinges up first, bring in a null. In our tools menu, we'll go to duplicate. We don't want 8 copies, we simply want 4. We do want to do it in linear mode, that's fine. We don't want to do it along the y-axis. We simply want to say 20 in the Z, and then we can hit apply. And straight away we've got our nulls. Let's just put that in there, and I'm going to rename this inners for inner hinges. And then we'll rename the nulls, and this will be I5, 4, 3, I2, and I1. So there are inner hinges set up. We just need to come into our object tab here and we'll change this to circle, change its radius to 2, and in the basic tab I will give these a colour, so let's just make them yellow. Okay, that's fine. So if we hit H, we can see where we are. We've got our first position set up. And then if I switch to my top view and hit H again, we can see that they're 4 squares apart and each square is 5 centimetres. So they're perfectly aligned 20 centimetres apart, which is great. That's what we need. So that's our inner hinges dealt with. The next thing we need to worry about is marking the center points between these hinges, and that will be our next port of call. We'll bring in another null, drop this down here, we'll just close the inners, and this is going to be C4, but we won't rename it yet. We'll do the renaming once we've done the duplication. But C4, if we just move it into position, we'll move it so that it's at that position there. What I'll do, I think, is go into my object tab, select a circle, make it 2, basic tab, automatic, and we'll make this one green. Just bring that down there. Great, so we're on the road. So let's just come into the tools menu, duplicate. This time we want 3. And again, we should be okay to just hit apply. And we are, and we've got all our centers in place. So we can rename these centers, and it will be, where are we? Yes, that's C1, C2, C3, and C4. Let's just see what we've got. We need to reorder, so let's just do this. Should really have gone the other way, but it doesn't matter, we'll reorder. That's great. So C4, 3, 2, and 1. Brilliant. So that's our centers taken care of. We'll close those up, and then we're ready to move on from here, and this time we're going to need our outer hinges. Once again, we'll bring in a null, drop it down here, and we'll position this here. That's the starting point. Once again, I will go into my object tab and select circle and make it 2 in the radius. In the basic tab, automatic, and then we'll make this red. And now we're ready to duplicate. So tools, duplicate, and it can be left as it is, and we can just hit apply. And we've got our outer hinges in position, so we can call these outers. And then rename. So where are we? Let's see. Actually, we do need to reorder, so we can call this C1, or rather O1, I beg your pardon, O1, O2, O3 and O4, and then we must reorder, so this one at the top, and we're done. So we've got all of the positions, or at least the initial positions that we're going to be working with, set up and ready to go. That's fine, that's looking good. So the next thing then is to build the relationship between all of these and get them moving around. And that's what we're going to be working on in our next steps. Yet again, I'm going to bring in a null, and I'm going to call this one controller and add some user data to it. So add user data. I'll add a group, and I'll call this door controls, and I will remove it from there and drop my data into it. And this I'm simply going to call open close. It will be a float. It will be a float slider for the interface, a real value for the unit, and a step value of 0.01. A minimum value of 24, and I'll explain why in a second. And for the moment, I'm going to make this 80 because our maximum at the moment, this point is 80 away from 0 along the Z. So I'll leave that there for the moment. It will be changed later and you'll see why. Slider min and slider max we will check because I do need to clamp these values. So we're set up. We've got a minimum value of 24, which we actually need to be 80. We'll make that 80. And then we can hit OK. So we've got our door controls. It's ready to go. We can now think about bringing in another null, calling it Expresso. Add the Expresso tag, and we're ready to start building our first expression. First thing to do is just make this a little bit smaller, just to get it under control, I think. Just move that over there. Okay, so we're ready to bring our controller into the expression. Door controls open close, that's what we need to work with. And then in our inners here, let's just see where we are. So we've got I5. We've got it right. Okay, we've got an ordering problem here. Right, I1 is in the correct place. So look, so I4, we've just seemed to have got a bit of an error here. Let's just sort this out. So I2, we need to move that up there and actually rename it I4. I4 needs to move down to here because I3 should be in the correct place, and it is. So this just needs to be renamed I2. And now it's 5, 4, 3, 2, and 1. That's fine. Okay, so all is good there. I should have reorganized the inners as I did the centers and the outers. We need to bring in I5, and we need to say coordinates, transform position, position Z. Bring that into there and plumb those two together. Now at the output stage, we need to say transform position, position Z again. And we also need previous position because we're interested in checking that. So that's set up so far, and we can just expand the window a little bit and bring in a vector to reals, so adapter vector to reals. And we will plumb in the output of the previous position into there. And then we can bring in, let's have a look, see what we need. Yes, we need a compare. So we'll bring in one of those, a logic compare. And its function needs to be less than or equal to. And we can plumb the position Z into input 1 and the Z from the vector to reals into input 2. And then just to check to see what's going on in here, let's bring in a result node and we'll put the output into the input there. At the moment we've got a 1, and that's because our position Z and previous position Z are currently both equal to each other. We'll grab a hold of our controller here and let's just see how this is working. So if we move this, we can see that it is moving our I5, which is what we want it to do. At the moment we're getting a 1. If we move back this way, we probably are getting a 0, but it's probably sporadic. You probably just about see it flick on and off. If I move that, that's what should be happening. So it's only 0 when we're moving in a greater direction, and it will be at all times, but you only see it just flicker there. So that's working as I need it to. That's the first little bit of this expression complete. Moving on from here, we can think about working with the rest of our inner hinges and how we're going to make those move relative to each other. Let's just make the window bigger, and then we can think about where we're going from here. The first thing we need to bring in is an iteration. So we'll bring one of these in. Its start will be 0 and its end 3. The next thing we're going to do is bring in 2 linked lists. So we'll bring in 2 of those, just command drag to copy. In our top linked list here, we will need, we just move the window a little bit, we're going to need I5, 4, 3 and 2. And in the bottom linked list, I4, 3, 2 and 1. So we're going to be looking at these objects in pairs. We're going to be comparing this one to this one, this one to this one, this one to this one, and this one to this one. That's the relationship we're going to be building between them. The next thing to do is bring in I5, and we'll also bring in I4, just to distinguish between the two. We need to connect our iteration to the indexes of both our linked lists, and our links we can connect to I5, give that an object port, I4 and give that an object port at the input stage. At the output stages of both of these, we need coordinates position or transform position, position Z. So we'll get those sorted out. And we've got that done. We can just command click to make these bigger so that we can see what's going on. And then the next thing to do is actually bring in a math node. And it will be a subtract in the function. Place it down here and then plumb these two in. So we're going to subtract the position Zs of our second group of inner hinges from the position Zs of our first group of inner hinges. Let's just take a look at what this is going to do. So we know that if we come into our coordinates here, I1 is at 0 along its z-axis, I5 is at 80, and our remaining nulls are positioned at intervals of 20 centimetres along their z-axes. So we can positively say then that we're at 20 here, 40 and 60, and we're going to subtract 4 from 5 because we said that we're going to be working with the positions of our nulls here. So we're working with I5 through to I2 in this particular list, and then I4 down to I1. So we're subtracting I4 from I5, I3 from I4, I2 from I3, and I1 from I2. And that gives us a maximum distance of 20. That's what we want. We want a maximum gap, at the moment anyway, a maximum gap of 20 between each one. So that's why we're doing this. Hopefully that explains why we're using the subtraction, and it's all perfectly clear. Moving on from here then, we can bring in some compare nodes. So let's bring in 2 of those. Just bring in one there and command drag to copy. And into these two, we can plumb in the output of our subtract into their input ones. Now our functions, we can select both of them because these are both going to be less than. The top one will be less than 20 and the bottom one less than 6. So provided we've got a gap of less than 20 here, ultimately we're going to be saying leave this where it is. So if this was down here, but we still had a gap of less than 20 between I5 and I4, I4 would just remain in this position. That's what we're ultimately going to be doing here, because we don't want it to move until the gap is 20, and then it will be dragged along by I5. And the same will apply to all the others. Of course, this one's fixed at 0. It doesn't move anyway. But that's what we're about here. And then with our bottom compare, if we're less than 6, so if I5 has got within 6 centimeters of I4, then we will want this to move downwards. And again, it will be the same rule that applies to these nulls here. So that's what we're doing, okay? That's what we're ultimately going to be aiming for. Moving on from here then, we can command drag to create another subtract and do the same again so that we've got another 2 subtracts available to us. Now, what we need to do here is plumb in the position Z output from our I5 node here. So that goes into there and it also goes into here. So those two are now plumbed in. So what are we going to subtract? Well, in the top, we're going to subtract 20. And here we're going to subtract 6. And if we look at our nulls again, so once we've actually, what we're going to be saying again in here is, oops, don't want to do that. What we're going to be saying here, once we've actually got a gap of at least 20, or once it's at 20 or trying to exceed 20, then we're going to drag this along with it. And again, the same applies to the others. So that's what we're doing here. Once we've exceeded, or 19 really, I suppose, because obviously our function is less than 20 in the compares. So once we've hit 20, we're going to actually drag this along. And again, in this compare here, less than 6. So once we're within 6, we're going to push these downwards. And that's what we're going to do. We're going to hold them at those positions using these subtracts. So we're going to keep a gap of at least 6 or a gap of at least 20 when we're moving in whatever direction we need to. So if we're moving in a minus direction, it will be a gap of 6. If we're moving in a positive direction, it will be a gap of 20. So that's what we're doing there. Moving on from here then, we need 2 conditions. Bring in the first one and command drag to copy. Now these conditions are going to be switched by the compare nodes. So the outputs of the compare at the top will be switching this one, and the compare at the bottom will be using to switch this one. Let's just move these into slightly better position so that we can see what we're doing more easily. We just move subtract. I'll tell you what we'll also do. We'll move these out of the way. Just move the subtract up there so that we've got a better view then, and we can see what we're doing more easily. So our subtract here, this needs to be plumbed into our input number 2 of this condition. This subtracts output actually needs to be plumbed into the input number 3 of the bottom condition. So it's slightly different. So that's all set up and ready. The next thing we need to do is plumb in the position Z's from here. The position Z from here has got to be plumbed into here and also into here. We just move that down so that we can see. So that's what we need to do there in order to make this work. So we're either going to be 20 units or 6 units away from here. So this is if we're using I4. it's either going to be 20 or 6, or it's going to be left at its current position. That's what we're doing. So this here allows us to leave them at their current positions when we need to. So that's the next step. The final step is to bring in another condition. So again, we'll command drag, drop this down and place it around here. And now we can actually get a hold of these and move them. Let's just get all of them. Oops, just get all of them there. That's it. Just move these over here, because this condition is going to be switched by this compare. So that's switched there. And then all we need to do is plumb the output of this condition in here and this in here. So when we're moving in a negative direction, we're going to switch to this bottom set of nodes. So what's being driven here? We're going to be using the bottom linked lists, positions, and the math subtract here. So that's when we're going in a negative direction, and then that will be plumbed into here. And then when we're in a positive direction, we're using everything that's in the above section here. All of this will be used. So that's what we're doing, and that's how this relationship is going to be built. Finally, I'm going to bring in I4, drop it in here, say coordinates, transform position Z, and we'll also give it an object port, make it a little bigger and bring it down here so that we can see what we're doing. We'll just make the window bigger. Okay, and now what we need to do is simply bring the output of this linked list into the object port, because we're interested in these, because these are the ones that are going to be moved. Admittedly, we're not going to be moving I1 because that's fixed in its position, but that's fine. We still need it in the linked list. But the other three are the ones that we're going to be interested in moving relative to I5 and, of course, their neighbours. So that's what we're going to be doing there. And then finally, we can plumb the output of this into position Z. Now, all things being fair, if I use my controller, things should actually work. Let's see if they do. And look at that. So they're all moving. They're keeping that distance absolutely correctly. And if we move now, because we're actually heading in a positive direction, but we're less than a gap of 20. Now we've got a gap of 20, so now we're actually dragging them along, and the others are staying where they are. And again, if we push this down here, we can create that chaotic situation that I mentioned in the introduction. They don't have to be uniform. They can be completely chaotic. So it's all working exactly as it needs to work. And that's great. That's the second part of this complete. Moving on from here then, we need to worry about what we're going to do with the centres, and they need to maintain a central position between each of their neighbours. That's exactly what we've got to do. So that's actually very simple to set up. The first thing we need to do is add a position Z port to the output stage of I4 here. And then we need to bring in a math add. So we'll command drag to just copy one of these subtractions here. Change the function to add. And we need to add the position of our linked list here. We've got to take this output. So we need the positions of these four that we've got in this linked list. So we grab a hold of those and we'll connect them to input 1 of our math add. And then we also need the positions that are in this linked list as well. So we've got to add these two together. We've got to add these to these, and then we're going to divide by 2, which will give us the central position. But don't be tempted to drag this from here and plumb it in here, because if you do, you'll get a lag problem. It needs to come from here. So take it from there and plumb that in there. So that's the add taken care of. We'll command drag to copy again and bring this down here, plumb the input into or the output, I beg your pardon, of this add into the input 1 of the math add. Change the function of our math add to divide and say divide by 2. And then what we need to do next is simply pull in, if we just close our inners and open our centres, we'll pull in C4 and we will give this a position Z port. So transform position, position Z, just make it a little bigger, and we'll also give it an object port. That's got that done, and then we can actually plumb the output of the divide into the position. Now we've got to get our objects, so that means we've got to create another linked list. So we'll command drag to copy this one. Select everything that's in it because we don't want these, but we do want C4, C3, C2 and C1. Plumb the iterations output into the input port, the index input port there of that linked list, and then all we've got to do is connect the output of the linked list to our object port over here. Okay, let's see what's happened. Now we've got some movement in there. Let's have a look and see what we've got. Let's just move this and just see where we are. Are we getting anything? We're not quite getting what we need, are we? So we need to do a little bit of a check because there's an error crept in. So we'll just see what's going on in here. Actually, I think I might know what it is. If we just move this out of the way, the centers, yeah, they're not quite in the right place. The group should be down there. Now let's just try this controller. Let's have a go. And now it's working. There you go. It's doing exactly what it should do. Fantastic. So that's there. That's looking good. And they always maintain that central position. That's exactly what I need them to do. Brilliant. So that's all working exactly as I want it to work. Now let's just check the outers. Right, so they're not quite in the right position either. What I'll do here, I'll just remove those from there and zero this out because they're going to be in the wrong place otherwise. So let's just put that back in there. That's great. So they're all where they need to be now. And they're the thing that we're going to be working with next, actually. We've got to get their positions worked out. So the first thing I'll do is bring in 04. Bring this back over here. And what we'll do, I'll just bring it here for the moment. I'll give it a position Z at the input and also an object port at the input. So that's ready for the first part of this. And then again, what I need to do is just move back over here. Command drag to copy this linked list, plumb in the iteration. And once again, we can remove these elements and replace them with 04, 03, 02 and 01. That's set up and ready to go. So we can plumb the output of the linked list into the object port. And then what we need to do next is bring this over here. And then we're ready to do what will be the penultimate step, which is to plumb the output of this divide into our position Z. And now, if we select our controller, we should find that we get those moving along with the centers, which is exactly what we want. We want them to maintain the same position Z as our centers. Fantastic. Now, the ultimate step is to actually move these along their x-axis, or their x-axes, I should say. Now, how are we going to do that? Well, you can see what we've got here is a triangle, so we can use Pythagoras theorem. We know that this is going to be a completely changing dimension here, because when we move the controller, we can see that that's exactly what happens. So the distance between our inners and centers is variable. And we know that this needs to be a constant length because obviously these represent the doors. This is where the doors will actually be. So this length must be a constant length. So if we just set this back to 80, we need to find out what this length is. Well, we can do that, can't we, using Pythagoras theorem. So if we know that this is 10 and this is 10. So 10 squared is 100. So if we know that both these dimensions are going to be 100 squared. So if we add 100 to 100, we're going to get 200. And so we've added those two together. So we know that that squared plus that squared is equal to the square root of this. So what we need to do now is find the square root of x, and we get 14.142. So that is the length of this. 14.142. That will be accurate enough. That being the case, let's bring in a constant node and make our constant value 14.142. So that gets the first part of our Pythagoras theorem underway. And let's just move this over here and just make some space. So where do we go from here? Well, the next step is, of course, to bring in a float function. We want it to be power of 2, and we need 2 of these, so we'll copy one. We're going to plumb our constant value into the value input. And now we need to think about what we're going to do in order to get our next value into here. So what are we going to do there? Well, the first thing we need to do is bring in another math node. In fact, I think the easiest thing to do will be to copy this math divide. And we'll make this function as a subtract. So that's ready to go. So what are we going to subtract from what? Well, for a start, we need to add a position Z port to C4. So this node here, let's just move these along a little bit. So we're going to be subtracting the position Zs of our centers from, and we need to make the window a little bit bigger, I think, just to see what we're doing. Once again, what we're going to need is this output here. As this is so big, I will move my subtract node a little bit further over to the left of the window, and I'm going to connect this to the top input into input number 1. And then all I need to do is bring this over here, plumb in the position Z from C4, and then this can be plumbed into the value for this float function. And then once again we need to command drag to copy this subtract node and then subtract the 2 of these. And then the final step is to, once again, I'm going to command drag and copy the float function and just change its function here to square root. Plumb this into here, and then we simply need to give 04 a position X port at the input stage. Just make it a little bigger. We can leave it there actually for what it is. I don't see why not. That's okay. It seems all right where it is. And then we can plumb that into there. And let's see if we've now got what we want. So when we move, yep, we can see that we have. That's doing exactly what it needs to do. So that's great. It's maintaining the length that we need it to in order to make our doors function correctly. Fabulous. And that completes this expression. Let's just bring it over to here, hit H so that we can see it all. Just bring that over. And there's the complete expression. Quite a large one on this occasion, but quite a powerful expression, as you can see. And you can think of it in 4 different steps. We did this piece first. So this was just to get our controller to move the I5 null here. That's all that's doing. And then we started to do some interesting stuff here, and we subtracted the nulls in our bottom list from our top list, and then started doing compares to see what they were doing. And of course up here we've got this compare driving a condition here that allows us to swap between two sets of mathematical conditions technically, which are constantly being worked out. I mean, both of these are being done at the same time. They're just used at different times. So if we're moving positively, we use the top section, and if we're moving negatively, we use the bottom section. But they're both calculated at exactly the same time. So that's what we're doing there in order to make our inner hinges behave the way we want them to. We then worked with our centres, so we've got these being worked on here. And then finally we worked on the outer hinges down here. So there's 4 definite sections involved in the creation of this particular expression. And that's the way I've chosen to do it. So that you can see that it just goes in, well, you can see the data flow technically. That's what I'm showing you here. So that's all you need to do, but it's just remembering to sort of set it up in 4 separate sections. If you do that, you make life easy for yourself. But that's our first expression complete and taken care of, and all working beautifully. So yeah, that's all very nice. Now earlier I did mention that I was going to change some of the values, and I just set it up the way it is now because they were easy values to work with in order to make this happen. What I need to do now is make it so that things behave slightly differently, because what you've got here, if you look at where we've got it set up, the doors are still sticking out a long way. What I want them to do is go flatter. I want them to go closer to the center point. I don't want them to go totally flat, because I don't think these particular types of doors ever do, because if you did get them totally sort of in line with each other, you jam them up. So you've got to leave a little bit of a gap. They've got to be sort of at a slight angle going through. Anyway, that's what we've got to sort out next. It's actually perfectly simple to do. In this compare, we simply need to just move this over a little bit. I'm going to change this value to 28.2 and do the same in this subtract. And then in my user data, select my controller and just go into my user data. I simply need to change a few variables in here. So where I've got 80, I need it to be 112.8, because that's 28.4 times, I'll break it down, 28.2 times 4. So 112.8 in there. And I need to do the same here, 112.8, so that we're matching up there. And then this can be 112.8, and we can hit OK. If we now move this, we should find that we get the result that we want. And as you can see, we do. We're moving it to there, and that's fine. And that will give us our doors almost in line with each other. And that's exactly what I said I wanted. Okay, great. So that's all you've got to do in there then. Just change the value in the compare and the subtract at the top compare and the top subtract. Change those two, and then just make the adjustment with your controller's user data. That's all you've got to do, and it works perfectly. Let's get this expression closed down and start thinking about our doors. Crikey, the window's big. Way too big, but we'll close it down anyway, and we'll worry about that later. Right then, let's think about the doors. The first thing to do is to bring in another null, drop it down here, rename it doors, and that's set up at the 0 position, which is where I want it to be. Moving on from here, I can bring in another 8 nulls. So 1, 2, 3, 4, 5, 6, 7, and 8. Drop these into the doors, and then we'll rename them. So we'll call this D8, D7, D6, D5, D4, 3, 2, and 1. And they're our doors initialized. They're ready to go. Obviously, they need to take specific positions from the hinges. So D8 will need to take the position of I5. The next 2 will need to take the position of I4, and so on. So we've got 2 pairs that are going to be attached here, here, and here, and then just 2 individual doors at the beginnings and the ends. So that's what we've got to achieve, and we've got to do that using another Expresso expression. We've also got to give each of the doors a target tag, because again, they've got to actually look at these. They must face in the direction of these. So along their z-axis, D8 here will actually, it'll be over here, and it will be facing in the direction of the outer hinge here. That's what we've got to make it look at. So we can either do that first or we can do the expression, and I think it's probably easier to do the Expresso first, and then we'll worry about the targeting afterwards. So let's start with that, and we'll give the Expresso null another Expresso tag. Get the window open and we'll have another go. Let's just make this smaller again because it's not a huge expression this time. The first thing to do is bring in another iteration, so we'll bring one of those in there. Ready to go, and we can set its end value to 7 because we've got 8 doors, so we're going from 0 to 7. Moving on from here, we need 2 linked lists, so we'll bring those in. Let's have a look, see where we are. So we've got a linked list and then another linked list. Now our top linked list will want to be our doors, so we'll bring those in, and they're set up and ready to go. And then in our bottom linked list, we actually want the hinges from our inners list, so these are going to want to go in here. So we've got 1, 2, 3, 4 and 5 of those. Well, that gives us a bit of a dilemma, doesn't it? Because we've got 8, well, technically we're going to count from 0 to 7, which is 8 values here. We've got 8 doors, but we've only got 5 hinges. And as we said, this is the situation that we need, because we need 1 door attached here, 2 here, 2 here, 2 here, and then 1, giving us the 8. But we're not going to be able to set that up here. So we need to reach for the ever faithful Python node. It's the easiest way, I think, to set this up. So in the Python node, I'm just going to get rid of both of the input ports. In fact, I'm going to get rid of the output as well. I'm going to add an input port, which it's going to be an integer, and I'm going to rename it simply I, because all it's going to do is take the iteration output. At the output stage, I'm going to add another integer, and I'm going to call this door, or rather hinge. Hinge is the better name, because this is going to be plumbed into our hinges. Okay, so what are we going to do with the actual Python code? Well, let's take a look at that. We'll just open it in our little editor here for what it is, because we haven't got to do very much. So what we've got to do is say global hinge and also indexes, and then all we've got to do is define them. Now we've got to say that indexes is equal to brackets. Now let's look at this. We need this to be our first value, so we need to say 0 which will give us, if we look at our linked list, this will be 0. So it will be 0, 1, 1, 2, 2, 3, 3, and finally 4. So that's what we need in there. And that way we're going to we're going to set up a situation where we can actually output these in the correct way in order to take the doors and actually give the doors the positions of the correct hinge. So that's going to work for us perfectly. And then all we need to do at the output stage is say hinge is equal to indexes square brackets I, and that will output the appropriate hinge index value at the appropriate time. And that's all we need to do in there. That's fine. That's all worked out. So we can now connect that to there. Our iteration can be attached to our index of the linked list containing our doors. And then we can worry about the rest of this. So straight away what we need to do is bring in I5, give it an object port at the input stage, and at the output port this time what we want is actually global position, which we're going to pass onto our doors. So we're going to actually open the doors. We can bring in D8. Once again, we can connect our linked list, give it an object port, and then finally add a global position port. So we've got that all sorted out, and we can just simply plumb that in. And what we should find, what we'll do in fact with our door nulls, we'll give these spheres and we'll make them smaller, make them say 3 this time, so they're slightly bigger than the circles. And we can see already that they're all in the correct places because we've only got 5. We've got 5 groups, haven't we? We've got an individual one here, we've got 2 here, 2 here, 2 here, and 1 there. That's what we've actually got. And in our basic tab, we'll simply say automatic and make these cyan. And that's all of those set up. So now we should be able to close this down, move our controller, and we find our doors are taking the position or the positions of our hinges here. So that's working exactly as it needs to. The final step for these is to actually give them target tags, and then we can physically make the doors and put those into place. But we'll give these target tags, select them all, animation tags, target, and now we've got to decide what they're going to look at. Well, obviously these first two, which are D7 and D8, which are here and here, they're going to be looking at this, aren't they? So they're going to be watching C4. So where we've got our target objects, we can bring in C4. And they're now looking at those. The next two, so let's have a look, see what we've got. Well, we've got one here, obviously. We've got D6 is here because it's at the same position as D7. So D6 and D5 are going to be looking at C3. So let's give those C3. The next, what are we doing next? Let's have a look. So D4, which is here, and D3, they're going to be looking at C2. And finally, D2 and D1 are going to be looking at C1. And that should work fine. That should work fine. So let's get the controller. Let's just make a move and we'll see what happens. I'm not seeing them rotate, which I was expecting to. That should be working. Let me just go back into here. So let me see what I've got. We're going to my top view. So F2 to go into the top view. Let's see what we've got here. So let's have a quick look. What are we looking at? That doesn't appear to be working for some reason. It doesn't appear to be looking in the right direction. It should be looking at C4, which is here. Well, C4 is actually C4. No, not. I beg your pardon. I've done this wrong. It's not the centres. It's the outers that they should be looking at. Ah, silly boy. Okay, so let's just swap these over. So they should be looking at D4 or rather O4. And now you can see that that's moved and the other one's moved. Let's just do this and that will be O3. Drop that in there. O2 and O1. And now they're all looking in the correct directions. And if we move the controller now, we find they do. You can see that they're rotating as things move. That's really working properly now. Fantastic. Yeah, so be careful. Don't get caught out like that. It is easy to forget what you're doing and just go for the wrong ones. But the essential thing is when you get to the doors, they need to be looking at these, the outers. Okay, that's fantastic. So up to that point, we're now there. We just now need to physically make the doors and position them within these nulls. And you'll see why as I do that. We'll get a cube and we'll think about resizing it. So we want the X to be 2, the Y to be 50 and 13.8 in the Z. And that gives us the size of our door. The next thing to do is make it editable. So hit C and then we'll look at our axis tool here, axis center. This is actually set up so it needs to be minus 100% of the Y and the Z. So we can hit execute and that will move our axes to the bottom right hand side of the door. So now we can simply zero out our door. And that initializes its position. It's not correct yet. We've still got work to do. But it initializes its position. I'm going to switch to my top view, so F2. And then take a look at what we're going to do with this door. The first thing we're going to do is move it -1 in the X. So that it's just about lining up with this point. But we've also now got to group this. In fact, what I'll do, I'll undo that. And then I'll group it into D1 first. And then we've got an angle here, as we can see. But what we'll do, move that -1 and then place -8 degrees in here. And that just about lines us up with the center of our outer hinge. And that's fine. I mean, what we can do if we wish to, we can zoom in and we can just tidy things up a little bit because it's a little bit off here. And what we need to do is just bring that somewhere around that point so that the corner of the door is lining up just about with the center. You can do it by eye. It does not have to be perfect, but that's pretty darn good and that's going to work out for us. So we've got that in position and that's ready to go. The next thing to do is to actually create another door. So let's copy this one and we'll group that into D2 and zero this out and we'll zero this out. That places it into D2, but we need to move this into the correct place. So we just put 8 degrees in there. So that's somewhere close to where it needs to be, but it's not quite there. We need to actually do some adjustment here because of course I think we've got to add probably something like, or in fact we may need to take off it in actual fact. Let's just take something off of there. Let's just take this down until it lines up with about there. That looks good. We've also got to think about, in fact, before we do that, let's worry about positioning the door. We've got to position this door at 1 centimetre along its x-axis. And you can see that this is perfectly mirroring the door that we've got in our D1 null. And that's exactly what we needed to do. So that's all great. Again, we can just move this over till it's just about in the center point of the hinge. We're just going to go in a little bit closer because I do have, actually I've got snapping on. Let's turn it off, make it easier for me. Just move that over until it's just about at that center point. That's fine, that's all good. So we've got 2 doors now in position, and if we go into our controller here and we just move this, let's just see what we get. So as it comes in, we can see that that's hinging the way we would like it to hinge. Not 100% perfect, but it's hinging okay. That's doing what it's meant to do. The reason it's not working completely accurately is because we need to just swap the position of that. There's a bit of a lag problem there. Let's see what we get now. It should be fine. Yeah, now it's working much better. That's great. That's looking really nice. Yeah. Okay, that's working fine for us. That's doing what we need it to do. So we've got our first two doors positions worked out. So what we can think about now then is just copying these doors and placing them in our other hinges. So, or in our other door positions, I should say. So if we copy D1 and paste it into D3, we can then 0 that out, 0 that out, and then move this to -1. That places that in the correct position, and we should, again, if we wish to, just have a quick look, see if it's in the right place. And it just needs that movement along the Z-axis just to there, and we can leave it, say, there. That looks good to me. And this is all you need to do, just this little bit of fine-tuning here and there, just to make the thing work as you want it to. We can now copy into D4 with our second door there, 0 this out, 0 this out, make it 1, and 8 degrees is fine. And then all we've got to do, zoom in once again and move this into position somewhere around there, something like that. That's fine. I mean, it is a little bit less than 1. It's not a major problem. But that's good. That's those two done. And then it's the same thing. Just rinse and repeat. We'll just copy this one into here. Oops, don't want to do that. Select that one. Just copy that into there. Copy D3, or rather D4. Copy that into D6. And then we can do the same again. We'll copy D5 into D7. D6 into D8. And then all we've got to do is 0 those out. So let's see where we are. So D4's just needs to be 0'd out. So let's have a look, see what we've got there. What have we got? Yeah, so just D4. We need to 0 this one out. So 0. And no, that's not the right one, is it? It's D5, I beg your pardon. D5's needs to be 0'd out. So 0 that one out. Make that -1. And by the power of editing, I will get the others done and come back to you. And there you go. That should be fine. So we've got all the doors in place. Let's just zoom out, see what we can see. And they all look good. I mean, it all looks perfectly natural, doesn't it? That's nice. So let's have a go with the controller and see what we get. And yeah, as you can see, it's all working really well. The doors are all aligning as you'd expect them to if they were real, and they're all working perfectly. So yeah, the whole thing is great, and we've still got that chaotic element to it, which is beautiful. So yeah, all looking really, really nice. I think I'm happy with that, and we can say that we've actually done the job. So that is how you create a rig for folding doors. And just to finish it off, all we need to do is group all of these into a null, and we can call this door rig. And now, if we wish to, we can drag this and position it anywhere in the scene, and it works perfectly. Absolutely anywhere that we choose to place it. And that's fantastic. So we can just place this back actually at 0. So if we Command Z just to bring that back into there, that's all good. Absolutely spot on. And it still works as it did before. And that just about brings us to the end of this tutorial, because I've shown you what I wanted to. And as always, I really hope you've enjoyed doing this one, and that it's given you some valuable information and techniques that you can apply within your own projects. And if you have enjoyed the video, then please give it a like. And of course, if you haven't already, then please subscribe to the channel and leave a comment and ring the bell. And wherever you happen to be on social media, then please share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, that just about brings the curtain down on this one, so I'll see you very soon on the next tutorial.